In this video, we are going to be starting our Unit B on radical functions. So you'll see on the front of your notes booklet, I have a graph. This is the basic graph of y equals the square root of x. So this is the graph that we're going to be working with in this unit, and we're going to be doing transformations on it just like we did in the first unit. So before we jump into this unit, there's a few things that you need to remember from your grade 11 PreCal course. The first major thing to remember is that we often have restrictions on radicals. So remember, we cannot take the square root of a negative number. The answer would not be a real number. So if we're working with square roots, the radical is only defined if the value inside the radical is positive. So there's going to be restrictions on the variable. Now it's also true when you have an index, of 2, 4, 6, 8, 10, etc. Any even number. The a value would have to be positive. Otherwise, the root is not a real number. Now if it has an odd index, 3, 5, 7, this a value can be any value. There's no restrictions at all. So if you look at the first example, I've asked you to state the domain, which really is just the possible x values for these functions. So you'll notice the first one is a square root. That means the value inside the root has to be positive. So that means that x would have to be greater than or equal to 0. Same for, I'm going to just jump to the side even though this is c. Same for this one. The square root of x minus 9. This has to be a positive value inside the radical. So x has to be greater than or equal to 9. For part B, question B, it's a third root. So that means there's no restriction. Inside the radical can be positive or it can be negative. Remember, with a third root, if for example we were asked to find the third root of negative 27, well, the third root of 27 is 3, so the third root of negative 27 would be negative 3. And the reason that we can end up with this negative in here is because two of these negatives would create a positive. This would be 9 times negative 3. So that's why in a third root, we can actually have a negative answer. In question D, again, it's a square root. It means whatever's inside this radical has to be positive. So 3x plus 12, you'll see I wrote out the algebra here. 3x plus 12 has to be greater than or equal to 0. And if you solve for x, we get a result of x is greater than or equal to 4. And for E, again, the index is odd, so this can be, x can be any value, xer. Also, remember when we're thinking about restrictions, that in grade 11, we also started looking at these rational functions where you have radicals on the top and bottom of fractions, and we also have to consider our restrictions in these scenarios. So in this part A, on the top we've got x minus 8, all under a radical. That means that x would have to be greater than or equal to 8, so that this is a real number. And on the bottom, we factor, and remember the denominator can't be equal to 0. So I factored this, and this means that x cannot be 4 and x cannot be negative 2. We're going to talk more about that in our next unit. For question B, we've got radicals on the top and the bottom. So on the top, there's no restriction. This is a third root, a cube root. There's no restriction on x. But on the bottom, we cannot have 0 on the bottom here. So the square root of 3x minus 1 cannot be equal to 0. So this means 3x minus 1 has to be larger than 0, because remember, it also can't be negative. And when I solve that, I get x is greater than 1/3. So even though on the top x could be any value, for the bottom to work, x has to be greater than 1/3. So the domain for this function would be x is greater than 1/3. There's a couple questions in your purple pre-cal review booklet for you to try out, and we're going to move right into the first lesson. So in this lesson, as I mentioned right at the beginning of the video, we're going to talk about transformations on radical functions. So before we can do those transformations, all of which you are familiar with from the first unit, we need to know what a radical function looks like. We sort of saw what a radical function looked like when we were talking about inverses of parabolas, but essentially, if I plug in values for x, so I'm going to use a table of values in order to graph this, I've got -3, -2, -1. I also threw in a decimal there just so you can see what happens. 0.25, 1, 2, 3. So I'm just going to plug those x values in. Now I've graphed two things here. The first I graphed was y equals x. That's the first function. And in the second one, I'm graphing y equals the square root of x. So for y equals x, we've got this point here. This is all the values of just y equals x. Now if I take the square root of that function, what ends up happening is for all these negative x values, I cannot take the square root. It's not a real number. So all of these points where the x value is negative don't have a y value that corresponds. The first point that we do have is 0, 0. And when we take the square root of 0, we get 0. So the first key point on the graph of y equals the square root of x is that the x and y intercept are both 0. Next, what you'll see is when you take the square root of 0.25, the answer is actually 0.5. Notice that number is larger, right? When we take the square root of a decimal, the result is a larger number. When we take the square root of 1, we get 1. When we take the square root of 2, it's approximately 1.4. Square root of 3 is approximately 1.7. And the square root of 4, I could have included there, is 2. So on this graph, you'll see I've drawn 3 key points, 0, 0, 1, 1. And this point here is x equals 4, y equals 2. Those are the 3 key points that you're going to use all the time when graphing these radical functions. If you notice, between 0 and 1, there is a slight curve, and that's because all these x values between 0 and 1 are decimals, and when we take the square root of a decimal, the result is actually larger. So it's got this little bump here. So essentially, this is like half of a parabola. So this graph has a few features. First, it's the shape of half a parabola, like I just said. It's got an x and y intercept at 0, 0. Its domain is x is larger than 0, and its range is y is larger than 0. Now, you can add this radical graph to your collection of basic graphs that you know. You know what a basic parabola looks like. You know what absolute value of x looks like, 1 over x. We know what straight lines look like. This is now just one more shape that you can deal with and apply the same transformations that we learned about in Unit A. So I have this table at the bottom of page 4 for you. And this table is just a reminder of all of these transformations. So now if you look at our function is the square root of x. I can apply vertical stretches and reflections and vertical shifts with a and k. And I can also have horizontal stretches and horizontal shifts with b and h. You'll notice now b and h are both under the radical with x, and a and k are outside of the radical. That's the biggest differentiator between vertical and horizontal, is that a and k are outside of the root, and b and h are inside of the root. A, b, h, and k all do the exact same thing that they did in our first unit. So if we look at an example on page 5, describe the transformation of y equals the square root of x to y equals -2 times the square root of 4 times x minus 3 plus 1. So again, I start by looking at the vertical stretches, reflections, and shifts. The A value is -2. That means I have a vertical reflection, a vertical stretch by 2, and this plus 1 means up 1. Those are all my vertical transformations. Horizontally, inside the bracket, I have a horizontal stretch by, remember, 1/4, because it's always going to be the opposite, and I'm moving to the right by 3. So you could take that basic radical graph and do these transformations to it to get your new function. In example 2, I've asked you to sketch the graph of this. So in this case, I took the first basic graph that I showed you, the point 0, 0, 1, 1, 4, 2. Those are my 3 key points. And I've done exactly what I did in the first unit. First, the A value is a vertical stretch by 4 and down 5. So that means my Y values are being multiplied by 4 and then subtracting 5. For the horizontal movements, we've got -2 and a 3. So we have a horizontal reflection, a horizontal stretch by half, and we're moving to the left by 3. So my X values are getting multiplied by -1/2 and subtracting 3. So if you look at these points, when I plug in 0, 0, I get -3, -5. When I plug in 1, 1, I get -3.5, -1. 4, 2 becomes -5, 3. And if you plot those 3 points and follow that the origin here, 0, 0, moved down to -3, -5, that tells you which direction to connect your dots. So this is you can think of this as the bottom of the graph and up to here to the arrow. Finally, in example 3, this camera got really crooked. In example 3, I've given you a graph and I've asked you to determine the equation for this graph. So instead of giving you an equation and having you graph it, I'm asking you to do the opposite. So the first point that I always look at is that point 0, 0. This key point 0, 0 moves left and right, and by doing stretches, it doesn't change. So 0, 0 tells you your H and K values because it's not impacted by any stretches. So the point 0, 0 moved over to the point 2, 1. I know this is H and K. So what I did was I plugged these. I can actually write this in here. So Y equals A B times X minus 2 plus 1. This is what I know so far. I know my H and K values. But what I don't know is I don't know my A or B values. Now, it's possible that I could have an A and a B value, but any vertical or horizontal stretch can always be obtained just with one of those values. So what I did in this case is I put in H and K, and then I pulled another point off of this graph. So I chose the point 3, 1, right here. And I used it to solve for B. So you might be wondering, why did I solve for B? You could also solve for A. You can choose one of them. Like I said, these transformations, you can get this resulting graph with just an A value or just a B value. I chose a B value, and when you plug that B value in, or leave it, blank, and plug in the other point, 3, 1, you're able to simplify this. So 1 minus 2 is -1 times B. Move the 1 to the other side, so that equals 2. So then I know if I square both sides, that -b equals 4, which means b equals -4. So this is a horizontal reflection, and a horizontal stretch by 4. You could also notice that there is a horizontal reflection because we can see it. And if you plugged in a negative for that horizontal reflection and then solved for A, you would get an A value of 2. Both of these equations result in the exact same graph. We just get there in a different way. So that's your introduction to radical functions. Try out the homework questions, and as always, let me know if you need any help.